Hello, welcome to Tech Transform. In my last video, I have already given an introduction about what is Spark and what it is all about. But here I am going to discuss something more about Spark and why we need a Spark. And once we cover these things, then we are going to install Spark on Ubuntu. So that's what these two agenda of this session. So let's start with Spark Advanced. As we already know, it's an analytical engine. It cannot do, but it's an analytical engine. It's a computation engine, but it cannot do all this computation by its alone because it's due to this it provides API to interact with the Spark frameworks. So APIs available are application programming interface available are different programmings are Scala, Python, Java, and R language. So in from these two combinations are very popular, like Spark with Scala and Spark with Python. Now the question is when to use Spark with Scala and when to use Spark with Python, and what is the difference between using these two combinations. So Spark with Scala is very faster, and because Scala Spark itself is written in Scala, so a lot of libraries Spark utilize of Scala, and a lot of features you are going to get first in Scala Spark with Scala if you are using a lot of Spark framework features. And if you have certain business complex business analytics tasks to perform, it's better to you go with Spark Scala combination, because this combination for Spark with Scala is very fast. You're going to achieve that achieve that particular task in a very less time frame. So but in Spark with Python, that is called PySpark, it is little bit slower, and it is if you have to perform a statistical operation, then you should go with Python, because Python is very rich in statistical. It has a lot of third-party libraries, lot of libraries built on the internet. If you are going to perform machine learning, a lot of machine learning algorithms also inbuilt in Python. If you want to perform the machine learning and all those, so you should use Spark with Python. Also is Python have its visualization techniques where you can visualize your data. So in that scenario you should use Spark with Python. So these are the basic differences why we want to go with these combinations, Spark with Scala and Spark with Python. Now there is a let's say we have a why we need Spark SQL, why we need Spark streaming. There's a question because these are the components of the four components of Spark. Spark, like Spark Core, Spark Streaming, Spark SQL, Graphics, and MLlib. So why we need these components? Let's understand each in more detail. So I'm going to first take. I will give you some examples for static data sources. Let's say uh, now understand exact use of a Spark is. Let's say we have a static data sources like data in SQL, DB2, Oracle, Teradata, Data Warehouse, file systems, any file systems like text file, window file system, Ubuntu file system, JSON file, Avro file, Pocket files, CSV files, ORC files, and all these all comes under the static data sources. So if you are going to Spark provides you a Spark SQL component. You by utilizing this Spark SQL component, you can connect to any of these data sources and pull the data. So that's what the Spark framework is very powerful. It can connect to any database, the old database, and it can give you it can pull the data from any static data sources. For pulling the data from any static data sources, we have to use a Spark component called Spark SQL. But let's say also we have in spite of static data sources, we have dynamic data sources also. What are the dynamic data sources? Like live streams of data from Facebook, Windows log, IoT devices, sensor data. These are the dynamic data sources. Facebook is generating a lot of data, YouTube data, Netflix data. These are the dynamic stream, and you want to pull the data from these dynamic streams. You are going to use that Spark component called Spark streaming, and you can pull the data on a real-time basis and perform the computational logic in what you want to do using a Spark streaming. So that's what the power. Spark is also providing Spark Graphics. Spark Graphics is library mainly built for, let's say, we have a social networking data, we have a travel data, social networking data called which friends are linked to which friend, which are mutual friends and all those. These are the actually the graphs related data of the social networking site. Let's say we have a travel data like starting from source to destinations. So how these are going to link to each other, these are the graphs data, and you want to visualize that, you can use that Spark Graphics library mainly used for these type of data. Then another comes the machine learning libraries, MLlib, provided by Spark. What are those? Let's say you want to do a recommendation, create a recommendation system of movies. Let's say you want to use recommendation systems for the products to you're going to recommending to the viewer, like products on Flipkart and Amazon. When you log in and you're some buy due to your whatever you have bought in if past, based upon that. Uh, Flipkart, Amazon as providing you the they are recommending the product to you in front of you so that their sale can increase. So in this scenario, you're going to use machine learning algorithm provided by Spark, because let's say you have to detect fraud detection. You want to know how many visitors views in my website, what are the potential viewers, those are actually their buyer or they are just one time user. So in order to do all this analysis and want have to create recommendation system and take decision based upon that, the machine learning algorithms provided by Spark MLlib. So we are going to use that Spark MLlib machine. They performs pretty very good also. But you cannot you cannot take data as it is you're getting from these sources. You're getting data from Spark SQL, you're getting data from Spark streaming. You have data already for Spark MLlib, for Spark Graphics. You cannot take data as it is coming from source. Before that, you have to pre-processing the data. Let's say you have to remove unwanted data. You have to handle null values. You have to make from unstructured data to structured data. You have to perform some statistics. Then the whole thing is going to come under Spark core. So all these components which I told you, SQL, Spark streaming, Spark graphics, and machine learning libraries, these all are going to depend upon the component called Spark core. So that is the basic backbone of all the components and the main base of the Spark framework, that is called Spark core. We are going to learn in the next upcoming sessions what are the Spark core. That is going to be a very separate topic. So let's move on in our slide. You can see growth rate of Spark versus Hadoop. So this data has been taken from Databricks. Databricks is now a main vendor of supporting Spark. They are supporting Spark, and in the last just 5 years of time frame, their revenue is close like in comparing to 25 years of Microsoft. So a lot of people are investing in Databricks nowadays, and this is the main company right now. It's it's promoting Spark like anything, and any new version, anything is going to support it by this. You have tons of tutorials. You have your online notebook libraries where you can write your Spark or Scala code provided by Databricks. So do visit one, just to Google search. I will also show you why this Databricks is a company. It's promoting Spark. So you can see how the growth. Initially we have Hadoop, number of contributions to the Hadoop project. See now as this current year, see the number of contributions to the Spark project is contributing a lot of, because now a lot of companies started using Spark for their analytic work, because Hadoop has some limited scope for those tasks. So what are the drawbacks of Hadoop? Spark worked on that, and they created a Spark framework. As we already initially started as UC Berkeley in 2009, and it is now getting promoted by Databricks. Uh, it's a fast and general. This already we saw in our first video, that's called Spark Introduction. Most popular for running iterative machine learning algorithms, graphics. Why most popular for running iterative? Because machine learning algorithms, they keeps on running n number of times unless until they are going to achieve a result, or unless until your model is performing well. In that case, because Spark is running on in memory. So in order to running those iterative tasks again and again is very faster in compared to disk of for MapReduce in Hadoop. Because MapReduce in Hadoop, it's going to run on the disks, on directly disk, so it's getting a lot of time, so it's not suitable. Spark MapReduce in Hadoop is not suitable for machine learning algorithms. That's what the Spark, all people are using for a machine learning algorithm. They are using Spark now, and we already know that the high level API is also available in Java, Scala, Python language. Also it is integrate, but still the motive behind the Hadoop is the distributed data storage is still there, because Spark is just a computational engine. It's not a storage engine. It's again, yes, it has to rely for distributed storage. It is going to use Hadoop. So Hadoop is also, again, its current Hadoop is also a base. On top of that, Spark is a computation engine, and for this, for creating data lakes and creating datas of clusters, still we are using Hadoop file systems, and Spark can integrate all this very easily. So integration with Hadoop and its ecosystem, and can read existing data also using Spark. So you can see, if you are going to choose Java as your API language in Spark, let's say we are going to word count in Java MapReduce. See, we have to write 50 plus lines of code in order to count the word in MapReduce using Java. But see, in Spark you can do in just 3 lines of code. So it's very efficient, it's very faster in development also. Now we have to we have to see how we are going to install Spark. So let's open browser, download Spark. Here to have to click this link, desktop Spark. Once you have this Google search, then you can choose any version. Right now you can choose I am using 2.4, so let's say 2.4. So once you go inside that, it is also telling you this Spark version is compatible with Hadoop version. Let's say these are we are going to download Spark hyphen 2.4.0 bin hyphen Hadoop 2.6.6, means this Spark 2.4 version is compatible with Hadoop 2.6. So based upon what Hadoop version you are using, you should check the correct Hadoop version you have and install the correct Spark version. So that's how you have to download this this is the usual stuff. We are downloading this .tzz, the zip file. You have to download this, then you have to extract it, extract it, and you have to put inside work. Then you have to go the final folder. See, I have 2 Spark versions, so right now I'm using this. So finally you're going to get this this file after once you unextract the data from where we were showing you this file. When unextract the data, you will getting these files. Okay, so this folder is there now. After that, you have to open your terminal in order to set the environment variable path in .basrc file. For that, sudo nano .basrc. So this you have to set spark underscore home export. You have to create this variable export spark underscore home, then the path of your Spark library, this path, copy, then Control Shift V, you are going to get this path. Okay, so you have set at this Spark underscore variable now is referring to the path of your Spark. Then again you have to set like this. This is the usual stuff we used to do for all this environment variable setup. See, so you have to do is a $spark underscore home, then you have to refer -bin folder. Again also you have to do spark underscore home, refer you have to sbin folder. These 2 folders you are basically you have to specify bin and sbin. So that's all. After done these changes, Control X, then you come here and type Spark Cell. So this is going to start a Spark Cell whether you are going to write your Scala program, because this is the Spark Scala framework we are learning. We are using Spark with Scala. So here we are going to write a Spark program, a Scala program, in order to interact with Spark. You can do same thing with Python also. That has a different installation and all those. That is called PySpark. We will do in future with Spark with Python also. So this is Spark with Scala. Here you can write your Scala code to interact with Spark. So that's all for the installation. I was telling you about Databricks. Let's see. See, this is a Databricks. This is a company. They are promoting Spark like one cloud platform for massive scale data engineering, collaborative data science. So this is the community edition. This is free. You can create your login and you can work with their notebooks and all those things. It's slow right now. See, I will show you in the Wikipedia. Databricks. Wikipedia. See, Databricks is a company founded by the original creator of Apache Spark. Those who are the creator of Apache Spark, they founded a company called Databricks. Databricks grew out of the AMP lab project at University of California, Berkeley, that was involved in making Apache Spark, an open source distributed computing framework built on top of Scala, using Scala. So Databricks develops a web-based platform. So the website I just show you, that is the web-based platform for working with Spark, that provides automated cluster management and IPython style notebooks. We have IPython. We saw that Jupyter notebook, Jupyter notebook. So same type of notebook this Databricks also provide on web-based. In addition to building the Databricks platform, the company is co-organizing the massive open online course about Spark and runs the largest conference about Spark, that is Spark Summit. You can see the revenue, see the funding. In September 2013, Databricks announced that it had raised 13.9 million from these Hardees, and said it aimed to offer an alternative to Google's MapReduce system. The company raised 33 billion in 2014, 60 million in $60 million in 2016, 140 million in, see the growth, 140 million in 2017, 250 million in 2019, and 400 million in this is going to this funding is going to increase like anything, because a lot of companies are going to work with Spark, and Databricks as the commercial promoter for the Spark. So we have seen a lot of details revolving Spark, and in coming video I am going to actually start the Spark core, and then we are going to directly jump into the RDDs and resilient distributed data data set and all those coming in the Spark. So that's all for this video. Thanks for watching. Have a good day. Bye.